Welcome to this comprehensive tutorial on implementing data partitioning strategies in Java. Today, we'll explore what data partitioning is, why it's important, and how to implement various strategies effectively. Data partitioning is a process of dividing your dataset into smaller, manageable pieces. This technique is crucial for enhancing performance, improving data management, and enabling scalability. Data partitioning can be particularly useful in distributed systems or databases where data can be spread across multiple locations. Today, we'll cover several types of partitioning strategies: range partitioning, hash partitioning, list partitioning, and composite partitioning. Let's start by setting up our Java project. Open your favorite IDE, create a new Java project, and let's set up our package structure. We will begin with range partitioning. In this method, we divide data based on a specified range of values. For example, data could be partitioned based on age groups. Let's define a simple Java class to represent a user. We'll create a method named partition by age range that will take a list of users and partition them into age ranges. Let's implement that now. Here, we create a map of partitions and classify users into the defined age ranges. Now, let's simulate some user data and see this function in action. In the main method, we create a list of users and call our partitioning function. The output will show how many users fall into each age range. Let's compile and run our program now. As you can see, range partitioning allows us to quickly gather insights into our dataset. Next, let's move on to hash partitioning. This method uses a hash function to determine where to place data, which provides a uniform distribution. In our hash partitioning example, instead of partitioning by age, we will use the user's name as the key for the partition. We'll create a method named partitionByHash. Here, the hash code method determines the appropriate partition for each user based on their name. We will limit our partitions to 5 to keep it simple. Let's once again test this method using an array of users. As we can see, this method provides a more uniform distribution of data across the partitions. Now, let's delve into list partitioning. This strategy assigns predefined values to partitions, which can be very effective when you have a known set of categories. Let's implement the partitionByList method, which will separate users into partitions based on a predefined list of names. In this implementation, we first create a map for the partitions based on a list of predefined names. Then, we check each user to see if their name exists in our partition map. Let's run this code and see how users are distributed based on the predefined names. This could be very useful for organizing specific name data in large datasets. Finally, we'll tackle composite partitioning, which combines multiple partitioning methods. This is ideal for complex datasets that can benefit from more than one strategy. Let's say we want to first partition by age range, and then by hash for users in the same age group. Single age groups will be further sorted into multiple hashes. Here's how we can implement that. In this method, we first use the age-based partitioning and then apply the hash partitioning on each of the segments. This allows for a much more granular level of data management. Now, let's run this method and observe how users are organized into additional partitions. This effectively showcases the flexibility and power of composite partitioning. As we conclude today's tutorial, I hope you now have a deeper understanding of various data partitioning strategies. Data partitioning is essential for effective data management, especially as data sets grow larger. Each of these strategies may serve different purposes depending on your application context. Don't forget to like, subscribe, and hit the notification bell for more tutorials like this. You are now equipped to handle data partitioning in your Java applications. Happy coding!